All right, now it's time for learning how to manipulate. And that got your attention, didn't it? Creepy little teenagers. But we're learning how to manipulate K, E, Q, and Q. We could do it two ways, reciprocal rule and multiple equilibria rule. So first is the reciprocal rule. So here's just a general equation. We have A plus B yielding D. So we've talked about how the reactants react to produce products, but the products can also react to produce reactants. And so as a result, you can write this reaction either direction. You can write it this way, or you can write it this way. With delta G, it might be more spontaneous this way, so we write it that direction, but we can write a non-spontaneous reaction as well. So if you do that, you're going to change the K value just because we have flopped the products and reactants. And so therefore, in order to convert the KEQ from this reaction into the KEQ from this reaction, you just take the reciprocal of that particular KEQ. So if this one right here, if the Kc of this reaction, we'll just say it's 8, the Kc for this reaction is just going to be 1 over 8. So we're just taking the reciprocal of this value. And so that makes it easy to figure out what the KEQ is for a reaction if we know what it is for the reverse reaction. Remember Hess's law, where we looked at how you can add different reactions together to produce an overall reaction? And we said how whatever the delta H is, or delta G, delta S is for each of those, they would add together to give you your final one. We could do something similar with the multiple equilibria rule. So if we've got two different reactions like this, both at equilibrium, and we sum them together to get a total final reaction, if we wanted to figure out what the equilibrium is for this reaction right here, we would just figure out what the K is for this reaction, the K is for this reaction, and we would multiply them by each other in order to get the overall K. So the equilibrium constant for this reaction times the equilibrium constant for that reaction is going to equal the equilibrium for that one right there.